Welcome to qnawire.
Hi, so over here we're going to have a couple of problems in which we need to find the volumes that we need to that are going to get produced. So for the first one, we're going to have a relationship in between the density of isopropyl alcohol and the mass that we're going to have. Remember that density is equal to mass divided by volume, thus the volume would be equal to the mass divided by the density. So this would be 43.7 grams divided by 0.785 grams per milliliter. Thus, the volume that we're going to get would be equal to 55.7, rounding up to three significant digits, milliliters, corresponding to option A. Now, for the second question that we have in hand, we are asked how many milliliters of a 2.25 molar sodium hydroxide stock solution is required to make 525 milliliters of a 0.340 molar sodium hydroxide solution. So over here, we're going to employ, in a hidden way, the conservation of mass principle. We're going to have that the concentration of the stock solution times the volume of the stock solution is going to be equal to the final concentration that we require times the final volume that we require. Overall, what this is telling us is essentially that the amount of mole that we're going to add needs to be equal to the amount of mole that is going to be finally on our solution. So to know the volume of the stock required, we're going to have the final concentration that we have, the final volume that we have of the solution of the dissolution, and the concentration of the stock. So the final volume required is 525 milliliters. The final concentration is going to be 0.340 molar, and the concentration of the stock is 2.25 molar. So this is going to give us a volume of 79.33 milliliters, which, rounding up to three significant digits, 79.3 milliliters. And with that, it would be all. Thank you very much and have a good one.